Un šobrīd pēdējais ziņojums pirms pārtraukuma mūs aizvedīs dziļāk virtuālajā pasaulē. Šo prezentāciju klausīsimies tiešsaistē no Igaunijas. Un mums pieslēgsies Igaunijas Dzīvības zinātņu universitātes pētniece, doktore Floortje Vodde, lai pastāstītu par dabiskajiem traucējumiem, ekoloģiskajiem procesiem, kā daudzfunkcionalitātes vadlīnijām.
Thank you. Thank you very much for inviting me in this conference. I'm honored. Thank you for providing me the opportunity to speak, and to the audience, I also would like to say thank you for your presence here. This presentation is based on a presentation that I gave earlier this year in cooperation with Latvijas Biozinātņu, who also invited me to this presentation, to this conference. So ecological processes occur at many different levels, either simultaneously or as cascading effects. Some major examples are photosynthesis, including carbon sequestration, nutrient cycling, also food web interactions between all trophic levels, for example, woodpecker, bark beetle population dynamics, or the presence of symbiotic fungi to form mycorrhiza with trees. And these processes feed into the coexistence of species and the competition between individuals, both in the understory vegetation and in trees, and hence the successional pathways of forest ecosystems. So the within system processes in the middle in the green box here are largely environmental driven in the blue bordered box, with natural disturbances and their regimes among the main drivers. In the past millennia, and especially in the last couple of centuries, human impact has increased considerably, both directly through land use and fossil fuels emissions, and also indirectly through climate change. So next slide, please. Let's have a look at how climate and ecological processes have shaped Nordic and Baltic forests. There are three different biomes in the Nordic Baltic region, the boreal, the hemiboreal, and at the southern edges also the nimeral or temperate zone. So you can click. The further south, the more species come in, and now you can click down 3 or 4 times. So in order to of appearance from north to south, we first have several broadleaf species in addition to Scotch pine and Norway spruce, which are actually the only 2 coniferous species in a major part of the Nordic Baltic region. In the mid-boreal and south boreal, some more broadleaves come in, and they are obviously at the northern edges of their distribution. These are more convenient actually in the hemiboreal biome, where they are joined by some other broadleaves, and in the southern parts of Lithuania also some patches of larix and other species have migrated, which may also have been coming there naturally if humans had not assisted. The distribution ranges of species have always moved, grown, shrunken, especially due to climate change and also by the grace of refugia. When humans started to settle and transform forests into arable land, this gradually impacted tree species composition as well, and nowadays, since a few centuries, active forestry and the demand of markets have promoted commercially interesting species. So in Estonia, all species that came in since the last glacial period, they are still there, but the commercially non-interesting species have a more marginal distribution. And I guess that's the same in Latvia and in other parts of the world where forestry has intensified. So next slide, please. But with the current unprecedented rate of climate change, tree species distribution ranges are expected to shift relatively fast, mostly northwards. And here are some prognoses under sustained conditions and with 2.6, 4.5 and 8.5 degrees of warming. And also in more likely case of 4.5 degrees warming or 8.5 degrees warming in 50 years' time, Norway spruce and Scots pine, that's with a click, will disappear from a large share of the Nordic Baltic region. That's the red area. But even in the mildest case of 2.6, changes can be expected. So another click, please. With vegetation and tree species ranges, also forest biomes are projected to shift or even alter completely their composition with new tree species combinations. So next slide. Biodiversity is a prerequisite for resilience. If we want to have our forests in a more resilient state, that is better able to cope with the changing climate conditions and better able to recover from disturbances, high biodiversity at all levels is very important. So diversity at ecosystem, species and genetic level. They are inextricably linked with structural diversity and also functional diversity. And forest landscapes with a high diversity will adapt faster to changing conditions and increase our options to respond adequately to any type of projected or unforeseen change and help maintain sustainable delivery of ecosystem services. Next slide, please. Our future species communities very much depend on the magnitude of climate change and thus on the pace of migration, as well as the landscape heterogeneity, where in the more diverse landscapes and figure down, there is a higher likelihood of refugia present for species that cannot cope with migration speed. And instead of disappearing, they hide in those refugia. Also here, high species diversity increases future perspectives on functioning forest ecosystem. Finally, our choices also matter. We need to choose a wise frame of change while planning forest management. At intermediate levels of climate change, we may be able to manage for slight or moderate changes in species composition. But if the more severe scenarios tend to come true, we likely need to prepare for a complete forest biome change or even for a non-forest biome. And in that case, it may be wise to look at the options to introduce tree species from neighboring or more exotic vegetation zones suited to the new climate. Next slide, please. There are positive developments for biodiversity, such as the expansion of territories of brown bear here in Latvia and of Eurasian wolf towards Western Europe. However, in general, forest biodiversity is under a lot of pressure and threats. And in many cases, trends of species diversity go down. Most of the threats are directly or indirectly linked to human activity, be it the use of land or the conversion of land use, pollution, fragmentation, or active forest management, which has become, the forestry has become more intense and more whole tree harvest oriented over the past 50 years. So that means actually that it could also be in our own hands to turn the process around, possibly by the same means, wise choice of harvesting system and tree species composition. Next slide. Species diversity in itself, it's not the holy grail. Some systems are less diverse by nature, but most forests are naturally quite diverse. And sometimes there are biodiversity hotspots. You can click now, especially where the landscape is structurally more diverse. The variation depends a lot on many different things. Mineral soil patterns, for example, watershed conditions, connectivity between biodiversity hotspots, and other potential habitat in managed forest, where we also point at the importance of multifunctional use of forests. Most forest ecosystems are shaped by the local natural disturbance regime. The type of disturbances, frequency, spatial extent, and intensity of disturbances have a continuous impact on the conditions. And now, next click. To help to return forest ecosystems with more natural ecological processes. Several scientists have pointed at the natural range of variation in local disturbance regimes, be it stand replacing forest fires, river-related beaver ponds, or small-scale disturbance due to pests, for example. By streamlining forest management along with natural disturbances in terms of size of harvested patches, rotation lengths, structure, and species composition, there is often room for some mixture of silvicultural and harvesting systems, ranging from continuous cover forestry over retention forestry to clear cut. Next slide, please. The stable, balanced situation of a system may be maintained when processes affecting it keep within the natural range of variation, also called natural range or historical range of variability. That is in the green ovals in this graph. And ecosystems change, they develop, they get disrupted. And when a system is subject to a disturbance event outside its natural range of variation in the red circles, it may not be able to recover to pre-disturbance structures and functioning without help. And species diversity is quite a big cornerstone to restore these structures and functioning to increase ecosystem resilience. Clear references for an exact natural range of variation is hard to give for certain regions, but they are gradually put together from different studies. Next slide, please. Another confounding factor consists in the effects of cascading events, often incited or magnified by climate change, like here in southern Estonia, where after a summer storm in 2016, please click, we study the epidemic outbreaks of European spruce bark beetle, another click, and the spread of bark beetles outbreaks, they actually seem highly influenced by the extremely dry summer of 2018. You can click again. And therefore, we are now also including areas that are not affected by the storm, but had a high density of already weakened spruce trees with the outbreaks, where the outbreaks are likely connected to the weather extremes. Another click. This European-wide climate-related increase in disturbance impact, another click please, may cause landscapes to moderately shift with some changes in species composition, or to shift to an entirely different biome. Next slide. Yes, please, you can click until the end of the slide. Yes. That's it. When we tended to homogenize forest management in the past for efficiency reasons, it should be diversified in the to increase resilience and adaptive capacity. One way to achieve that is to adhere more to natural disturbances, which have also a lot of parallels with close to nature forestry. But that doesn't mean that we need to abandon clear-cut forests, for example. It should be a combination of all different systems, and most of it is based on the forest site type, where pine forests are growing and replaced by stand replacing forest fires. We can think about clear felling, whereas in Norway spruce forests, where there are small patches due to windthrow, we think about continuous cover forestry. So next slide, please. You can also click till the end of this slide. Yes, please. So this figure is based, the figure down is based on the ASIO model, a fire frequency model developed in Fennoscandia. And the left hand, the A panel of this graph depicts the old representation within green gap dynamics with parallels to continuous cover forestry, selective cutting. In orange, even age dynamics after stand replacing disturbances, and that has parallels with clear cut. And in yellow, the cohort dynamics, root cutting systems. And all these are distributed over different age classes. Now, with a revised conception in B, figure B, taking into account natural disturbance regimes, these three dynamics types would be more in balance, and about half of the forests actually would be over 150 years. That's the natural situation. But we are here as well, and to accomplish at least a change in the current situation, we could reconsider to change the land sparing versus land sharing principle. And land sparing is instead of just strict reserves and commercially managed forests, we could move more to land sharing, which makes more room for multifunctionality. So next slide, please. That's the final slide. So final wrap up by including ecological processes more as a guide in forest management planning. We extend the range of variation in ecosystem structure, provide habitat and an improved habitat connectivity for a wider scope of species, and increase ecosystem functioning, including resilience. And as it may not be sufficient to just rely on natural processes, we can help with tree breeding, genetics, hence improving species genetic material with an eye on climate change and future demands. Among several initiatives, rewilding and restoration are restoration options. Both concepts portray the introduction of key species as an important step for the restoration of natural processes. In the case of restoration, the aim is to render ecosystems especially resilient under projected future conditions. Hence, future-proofing Europe's and also Latvia's forests. So next slide, and thank you a lot for your attention and patience.
Okay, thank you, Floortje, very much. We have got some questions to you. Can we say that commercial forests also are multifunctional? People can pick berries and mushrooms, etc. People can run, walk, commercial forest products. Commercial forests can be multifunctional. What's your opinion about this?
Yeah, and I think that's already the case in many situations, but we still need to look for example, how we can manage also for carbon sequestration and to make more use of different forest products, to also use them in different ways. And yeah, I think that the valuation of the other ecosystem services is still a point to pay attention to in the future, because not everything has the same monetary value, and that makes it difficult to compare.
Yeah, okay. Multifunctional means multifunctional. What new tree species do you see in future in forests in Estonia, maybe after 20 years, after 50 years? Are you already planting a lot of non-native trees in your country, in forest land? Yes or no, and how it will look in future?
Our group has also experiments with other provenances, so the same tree species, but provenances from Latvia or Lithuania. And yeah, there are also experiments with non-native species. So I know that they are planting different types of maple. Yeah, I'm not that much into which species exactly comes in, but I know that there are many different initiatives going on to also use beech, for example, in a newly set up LIFE project.
Okay, we are going on with new tree species in future. Okay, thank you very much for your presentation. Thank you very much for your answers.